Welcome to the U.S. Military Test Prep channel by Study.com. My name is Eric, Marine Corps veteran, and I'm an ASVAB test prep expert. In today's video, we'll practice utilizing counting techniques and determining probabilities. This will help you prepare for the mathematics knowledge exam, which is one of the subject-specific sections of the ASVAB. Let's take a look at our first problem.
A 20-sided die is rolled once. The faces are numbered 1 through 20. Determine the probability of obtaining a number divisible by 3. 0.33, 0.60, 0.30, or 0.15. In order to solve probability problems, there are two key pieces of information that we'll need. We need to know the number of successful outcomes in the problem, and we need to know the total number of outcomes. So let's review the problem to see what information we're given to help us find those two pieces of information. So we know that this die has 20 sides, and they're numbered 1 through 20. So we know that the total number of possible outcomes is 20. Now, to find the total number of successful outcomes, we need to find how many numbers are divisible by 3. One way we might be able to do that is to list out all of the possible outcomes, and then we can count the number of them that are divisible by 3. Okay, with all of them written out, what are the numbers that divide easily by 3? So there's 3. And the trick here is it's every third number. So that's 1, 2, 3, 4, 5, 6. So our successful outcomes equal 6. So to solve this probability problem, we'll take successful outcomes divided by possible outcomes. So that's 6 divided by 20, which reduces down to 3/10. If we convert that to decimal form, we get 0.30. So the probability of rolling a number that is divisible by 3 out of a 20-sided die is 0.30. Great job. 2 cards are randomly drawn in sequence without replacement from a standard 52-card deck. Determine the probability of both drawn cards being ace cards, 0.14, 0.0083, 0.0027, or 0.0045. So we'll have to solve this problem in 2 phases because we're drawing 2 different cards and we're not replacing, so our numbers are going to change a little bit. So we know in order to solve probability problems, we need successful outcomes divided by possible outcomes. But because we're drawing 2 different cards, what we'll be doing is taking successful outcomes 1 over possible outcomes 1 times successful outcomes 2 over possible outcomes 2, because those numbers are going to change. Let's talk about why. So we know that it's a 52-card deck. So in our first draw here, we know there's 52 possible outcomes. 52 possible outcomes. Now, how many successful outcomes are there? It's an ace card. So we know that there's 4 ace cards in a 52-card deck. So there's our first answer. If we reduce it down, that will equal 1/13. Now in the second part of the problem, things have changed because we're not replacing. Here in the problem, we'll recall it says without replacement. So that means some of the numbers have changed. So if we assume that in the first draw we got our ace successfully, then that means there are only 3 aces left. So now our successful outcomes is 3. And there's only 51 cards left in the deck because that first ace has already been removed. So that reduces down to 1/17. So great, now we've got the information we need to finish solving the problem. So we have 1/13 times 1/17 equals 1 over 221, which works out to approximately 0.0045. So that's our answer, 0.0045. Great job. A die has 10 sides numbered from -5 to +5, excluding 0. If the die is rolled once, determine the probability of obtaining a negative odd number. There are a lot of different conditions in this problem, but it's still a basic probability problem. So we need to find our successful outcomes divided by our possible outcomes. Successful outcomes divided by possible outcomes. So let's review the wording of the problem so we can find this information. We know that the die has 10 sides, so our possible outcomes is 10. Now, successful outcomes could be a little trickier, so this is where it might be helpful to write it all out. -5, 4, -3, -2, -1, and we're excluding 0, so we skip 0, we go right to 1, 2, 3, 4, 5. So these are all of the 10 possible outcomes. Now what we're looking for is a negative odd number. So right off the bat, we know that none of these positive numbers are it. And then we can take out the even numbers, the -4 and the -2. So that leaves us 1, 2, 3 successful outcomes. So 3/10 is the probability. If we convert that into decimal form, that's 0.30. So that's our answer. Great job. A bag contains 36 red marbles and 14 blue marbles. 2 marbles are randomly drawn from the bag without replacement. Determine the probability of drawing a blue marble on the first draw and a red marble on the second draw. All right, there's a lot of conditions here, but it's really a basic probability problem. Now, because we know we're drawing twice and we're not replacing, some of the numbers are going to change. So we know that we need to find our successful outcomes on the first draw divided by our possible outcomes on the first draw times successful outcomes of the second draw divided by possible outcomes of the second draw. So let's start with the first draw. What are our possible outcomes? The bag contains 36 red marbles and 14 blue marbles. So if we add those together, we get a total of 50 marbles in the first draw. Now the successful outcome of the first draw is drawing a blue marble. So out of the 50, there are 14 possible successful outcomes here. So if we reduce that down, we get 7/25. All right, so now let's look for our possible outcomes of the second draw. Now the possible outcomes of our second draw is a little bit different because that first draw we'll assume was successful in drawing out one of the blue marbles. So now there's only 49 marbles left in the bag. And in this case, we're not looking for a blue marble, we're looking for a red one. So all of the red marbles are still in the bag. So that's 36. And this second draw is reduced down as far as it can go. So now we simply take the first draw, 7/25, times the second draw, 36/49. And to make our math a little simpler, we can do something fun here. Because we have a 7 here and a number that's divisible by 7 here, we can reduce this down to 1 and this down to 7. We just divided both sides by 7. So that equals 36 times 1 is 36, and 25 times 7 is 175, which equals approximately 0.21. So that's our probability, 0.21. Great job.
Okay, that's the rundown on utilizing counting techniques and determining probabilities. To recap, remember to read the entire question and consider what information you're being given to solve the problem. Sometimes writing the data sets out in ascending order can really help to think through the problem. The Study.com ASVAB course includes more information about what each subtest covers. The question content is similar to what you'll see on the ASVAB, and practice test scoring will be broken down by subtest for line score calculation. This can really help you see where you stand. If this video helped you out, give it a thumbs up. Drop a comment with any questions or topics that you'd like us to cover, and don't forget to subscribe for more U.S. military test prep content. I'll see you in the next video. You've got this.